Hello and welcome to the IBA's weekly announcements for the radio and television trade. Satellite television. Continuing our occasional series, today a look ahead to the advantages of the MAC system for DBS. In transmitter news, more extensions to the Channel 4 network and details of 3 new relays. In Sussex, Eastbourne, in Dorset, Chilfroom and in Devon, Clennon Valley.
In the previous part of our series on satellite television, we saw that DBS will allow most viewers to use a receiving dish 45 centimetres in diameter. When transmissions begin, hopefully in about 1990, we'll be using a new system called MAC. This is the standard recommended for DBS by the European Broadcasting Union. Much of the development work on the vision format for MAC was carried out by the IBA engineers here in Winchester. So why the need for a new system? Why not continue to use PAL?
The present colour television systems were designed many years ago. When colour started, it was essential that the millions of viewers with black and white sets should continue to be able to use them, receiving the colour transmissions in monochrome. The European channel plan for both VHF and UHF had been agreed some years before colour was contemplated. So the new colour transmissions had to fit within the same overall bandwidth already occupied by the monochrome signals. The answer, a frequency sharing scheme, a colour subcarrier placed at the high frequency end of the Luminance signal.
But there is a side effect for viewers watching in colour. The receiver's decoder can't distinguish between fine luminance detail and genuine colour information. The result, spurious patterning known as cross-colour. There's also another effect. The colour subcarrier produces a moving pattern on areas of highly saturated colour. This pattern of crawling dots is particularly visible on coloured edges. Once colour and luminance are mixed together in this way, it's extremely difficult to separate them again completely. Another less obvious disadvantage of conventional systems is that they're inefficient. Much of the time is spent carrying sync pulses and blanking periods. Only about 3/4 of the signal carries actual picture information.
We've already shown that DBS transmissions will use frequency modulation for the vision signal rather than amplitude modulation. This minimises the transmitter power. With AM, the received noise level is constant across the received bandwidths, but in FM systems the noise increases linearly in proportion to the frequency of the modulating signal. This doesn't matter too much for luminance, since the eye is less sensitive to high-frequency noise. But with the PAL colour signal carried on a 4.43 MHz subcarrier, the result is that all areas of saturated colour are more susceptible to noise. As the signal gets weaker, for example, towards the edge of the service area, noise on coloured areas of the picture shows up well before any other degradation. So while PAL and CCAM can work well, they're far from ideal for FM.
MAC stands for Multiplexed Analog Components. It does away with the colour subcarrier and so completely avoids the problems of cross-colour and cross-luminance. Also gone are conventional sync pulses, making room for extra sound and data channels, and even widescreen pictures. MAC keeps to the 625 line format, but each line of separate colour difference and luminance information is in effect squeezed, so that during each transmitted line, there's room to put first the colour difference, then the luminance. And this is what it looks like, in its compressed and undecoded form. We've added conventional sync pulses for this demonstration, otherwise you wouldn't see a locked picture. You won't see any colour here, it's just a monochrome representation of what the vision part of the MAC signal looks like before it's decoded.
On the right-hand side of the screen you can see the luminance signal. It's squashed to 2/3 of its normal width, from 52 microseconds down to about 35. To preserve all the detail in the picture, the transmission bandwidth has to be increased. The highest baseband vision frequency is 5.6 MHz. In PAL it's 5.5. With 2/3 time compression, the bandwidth must be increased by 3 to 2, or 50%, up to 8.4 MHz. Of course, here we're transmitting the signal over the conventional transmitter network, which limits the bandwidth to 5.5 MHz. That's why you can't see all the resolution gratings on the test card.
The picture on the left represents the compressed colour signal. This has alternate lines of the colour difference signals U and V. Each line is compressed to a third of its original 52 microseconds, down to about 17.5. The maximum baseband bandwidth available for the colour difference is 2.8 MHz, rather better than the 1.3 MHz of PAL. Don't forget that what you're seeing here isn't a full bandwidth max signal. That would require a transmission bandwidth of 8.4 MHz. Using the satellite, this isn't a problem, since when modulated the signal fits comfortably into the 27 MHz wide FM channel.
The result is a much cleaner, sharper picture than is possible with PAL. And because coloured areas of the picture aren't so susceptible to noise, it's possible to use a slightly smaller receiving dish. We've talked about the picture, but what about the sound? On UHF we use an FM subcarrier spaced 6 MHz from the vision carrier. Other European countries have different sound to vision spacings, typically 5.5 or 6.5 MHz. In France the sound is on an AM subcarrier. For DBS, the Europeans agreed that each television channel should ideally be able to carry up to 8 high-quality sound channels. The best way to achieve this is to transmit the sound digitally. During intervals between picture lines, the transmission switches from FM vision to a digital data stream. In the case of CMAC, the switching takes place at RF, with sound and data transmitted using phased shift key modulation. We'll have more about the sound part of the DBS signal in a few weeks.
Transmitter news next, starting with special announcements. In the Midlands, ITV from Sutton Coldfield is liable to reduced power this week, lasting until Friday. This is for aerial maintenance, weather permitting. Tomorrow, Channel 4 from Belmont will be off between 8:30 and 1:30, also for aerial maintenance. In Lancashire, the relay at Trawden is expected to be off today between 9:30 and 4:30 because of work by the Electricity Board. For the same reason, in Mid-Wales, Corris is due to be off on Thursday between 9:30 and 3:30. And Tregunnon is due to be off on Thursday between 10 and 10:30 for electrical maintenance. Also in Wales, Ponfadog will be off on Friday between 9:30 and 3:30 because of work by the Electricity Board. This will also affect Glyn Ceiriog.
In Sussex, the new relay at Eastbourne is now on the air. A number of viewers in the area with high-gain aerial systems on Heathfield or Hastings should change over to the new station to avoid interference. Hastings aerials can simply be redirected towards the Eastbourne relay, but amplifiers may need to be disconnected. About 5,000 people should benefit in areas previously unserved, together with another 4,500 people who previously needed high-gain aerials. Programmes from TVS South East and TVAM are on Channel 23, with Channel 4 on 30. The aerial group is A, vertically polarised. And our own Bernard O'Brien is in Eastbourne today, visiting dealers and members of the public. We'll be in touch with him during the day, so if you'd like to talk to him, please let us know. Our telephone number coming up shortly.
2 more relays are due on the air towards the end of the month. In Dorset, Chilfroom, HTV West and TVAM on Channel 45 and Channel 4 on 52. Group B aerials are needed horizontally polarised. In Torbay, Clennon Valley, TSW and TVAM on 49 and Channel 4 on 42. Again, it's Group B aerials, in this case vertically polarised. These relays expected on air by the end of the month.
Channel 4 next, and now on the air in Cornwall, Truro on Channel 54. This relay covers 1,500 people. Due this week, 3 relays in Scotland, Ballachulish on Channel 29, Onich on 54 and Kinlochleven on 65.
And that's all for this week, but if you have any technical queries on independent television or local radio, do contact us. Our address, Engineering Information Service, Independent Broadcasting Authority, Crawley Court, Winchester, Hampshire, SO 212QA. You can telephone our inquiry office on Winchester, area code 0962 822444. If it's cheaper, you can dial our London number 584 7011 and ask for engineering information. We'll be back on the air again next Tuesday at 9:15 and again in all regions except Wales at 12:15. So from John Lovell and from me, Maury Nicholson, goodbye until next week.